Hello everybody, John here, and today onto the garage we're doing part 2 of repair, test and understand your absorption fridge. So for those of you not familiar with the channel, To the Garage is a channel about sorts of things you can do, tinker, play with, repair and enjoy in your garage. I'm very into Jaguars, I'm very into Volkswagens and camper vans and everything that's connected to them. And I did a previous video on how to get these things working again if they fail. And in part 1, we covered the ammonia system, which is generally the cause of the fault. So go to part 1 if you've not seen part 1 yet, which is really easy to fix. Then we looked at how the gas system works, checking that out, cleaning it up, etc. So this is part 2. And sorry for the big delay between the two parts. Life, the world and everything got in the way. And this is an Electrolux fridge. It's a 3-way, which means it runs on gas, mains and 12 volt. This one happens to be an RM212, but they're all very much the same. The only fridge that is completely different would be a condenser fridge. And condenser fridges are quite rare in camper vans and caravans, unless the caravan or camper van is very big, or American vans do tend to have them. And you know them straight away because they're like domestic fridges, and when you turn them on they hum. There's a motor running, there's actually moving parts. There are no moving parts in an absorption fridge, so they are silent. There is nothing really wrong to go wrong with the fronts of these fridges. This one's got a panel missing off it at the moment, which would just be a trim panel. If you don't have one, or you're taking a fridge from a caravan like this one, and it's going to end up in a camper van, then you'd want to make a new panel up anyway. And literally a sheet of aluminium, a sheet of really thin plywood, whatever you want, cover it in Fablon or paint or leatherette, whatever your finish is, and then there's just a little trim piece, generally at the bottom. Occasionally it's at the top, and there'll be either a clip or a couple of screws. Whip that out and then bend your panel, slot it in like a picture frame arrangement, put this back in to stop it from falling back out. You're back to square one and it matches up with the rest of your vehicle. This one has got screws straight through it sticking out this way, and that's because it was a hidden fridge in a caravan, and this is where the door panel has been screwed on to the front to make it look like a cupboard. And whilst it looks like complete butchery, this is basically just a frame, like a picture frame. On the front is a piece of thick tin foil. Inside that there's a piece of polystyrene or foam insulation. And then on the back, we have this vacuum formed inner liner, and there's a rubber seal, and the rubber seal also contains a magnet. So that screw you can see from the front is just underneath that seal. It could be unscrewed, taken out. I won't need those screws because I'm going to have this in a camper van, and it'll have a sheet of ply in the front there, to which I'll put some leatherette, some vinyl that matches the seats probably, or the trim. So you can just pull this screw out. It is just a simple wood screw, and the seal, when it closes the door, shuts over that hole. So though you could fill it if you want with a little bit of bathroom sealant, it's not actually doing any harm. Almost without exception, these fridges, you can swap the door from a left-hand opener to a right-hand opener, vice versa. And that's because of the way the hinges and locks are done. A little hole here, press it closed, push that down, that locks. The hinge on the other end is actually exactly the same arrangement, but with a bracket on it. And if I take this bracket off, unscrew, 2 screws. What I can now do is just lift that out, and you can see exactly the same as this lock mechanism is this hinge mechanism. So I just take this literally, move it over to this side, and take this piece and move it over to this side, top and bottom, and you've switched which way the door opens. Okay, we covered the gas system in some detail last time, so we're not going to go over that. If you want to look at that, go to part 1 of this 2-part video. But the system at the back of all these fridges, though it might look quite complicated, is very, very simple and very, very similar. Cosmetically looks different. Sometimes these are covered up and boxed in rather than just lagged. This is the chimney. Or this coil might be a slightly different shape, or this might have round fins and be in a slightly different location, and this tank might look a little bit different. But essentially, you're looking at exactly the same thing on every fridge. Some will have this little tray, which is to collect condensation. Some won't, and I'll just have a pipe that goes out through the bottom of your van. So, how does this work electrically? This is a 3-way fridge: gas, mains and electric. In all 3 systems, it makes cold, again refer back to the first video, by heating this chimney. So warm air comes out of here, but it's not about the warm air, it's about warming this pipe that's running inside the chimney or alongside the chimney, and that causes the ammonia liquid that's inside here to circulate, and in doing so it draws the heat out of the fridge compartment. So in order for this to work, all you need is the heater inside here to actually be doing its job and warming this pipe. Now you can start hacking away at the insulation and undo all this, and on some fridges it's very easy to do. On some you'll end up destroying the heaters and things like that, so just proceed carefully. But basically, if the heater inside here, and there will be 2, a mains one and a 12-volt one, is jiggered, then I would suggest get another fridge. It's quicker, easier. But just for your interest, this one has a reasonable jacket to remove. So I've just undone the little like metal cable ties. Nothing clever about them, they're just metal because it's going to get warm. And we can open that up. So on this particular fridge, rather than there being a little jacket which usually looks like a white cloth with wires going to it, sometimes it's an orangey rubber, this one has got 2 little welded on tubes, one here, one just outside around the back, with a heater element going into it, and we can see the wires coming in here. So I'm just going to snip those for you to show you. Okay. Okay, so I've slackened the wires off basically, and now we can pull this heater up, and you'll see there's an earth lead, earth terminal. Just pull that off. There we go, finally. And this is your heater element. Now, as I say, if this is jiggered, I would suggest that fridges is nice and cheap and easy to come by, just go a different one. If this is just dirty, so sometimes the corrosion sort of builds up inside this tube and on here, although this should be stainless, and you don't get a good contact, you can improve things. But essentially that's your heater. And if you have access to heaters, you might be able to replace it, but not me. So all that happens is that is welded to that tube. This heating up heats up that tube. There's another one at the back. One of these is for the mains, which is this one, and the one at the back on this particular example is for the 12-volt system. And you can tell that because the mains one, whether it be 110 or 240, generally has thicker wires attached, or you can just trace them back to the switch if it says 12-volt and 240 on the front. So that's all that's going on inside there. Back up on top of the fridge, we've got, again, stuff that looks quite complicated but isn't. So over on the far side here, I have the piezo ignition. This is a sparker that lights your gas, and therefore it's got no connection at all with our electrical system, what we're looking at today. And this knob is to control the gas, and again, no connection. There's a wire, it's purely an earth, and that is to put to the chassis of your vehicle, to connect that to the pipework and help keep you safe from mains issues. So that, again, inconsequential in terms of how these things work. It's just earthing it like you would anything in a house. The gas pipe, so we're going to ignore that. This is the side we're interested in from an electrical point of view. We have a switch. It's a 3-position switch. Occasionally you have 2 separate switches. If it's a 3-position switch like this, the centre is off. On mine, this is to denote mains or domestic supply. So if you're plugged into the mains, use that, and the fridge will use the mains. Or down, it will use the batteries in your vehicle. Be aware, almost all, if not all, of these fridges, if you put it onto battery, it won't do anything unless the vehicle is running, because this will run down the battery, leisure battery or otherwise, in no time at all. So a lot of people think their fridges are broken because they put it onto battery. They've got charged up batteries in their vehicle and it doesn't get cold. And there's no indicator light on this to show that anything's supposed to be happening. It's because the vehicle's not running. Vehicle running, that should then send 12 volts to the 12-volt heater. This control, no knob on mine at the moment, is to set the temperature that you would like the fridge to achieve on electric. So let's turn the fridge around again and we'll just take the cover off of the electricals. The older the fridge, the less likely it is you've got a cover over the electricals. It's like health and safety was only invented in the last 20 years. And again, looks complicated, really isn't. So this is the knob that I said controls how hot the heaters get and therefore how cold the fridge will get. These are usually quite reliable. All you need to do is check that the terminals are well attached, clean and not corroded. So here's our mains supply. In the UK that's pretty easy to spot because we have 3 cores. So neutral's blue, live is brown, and we've got a yellow and green earth lead. Wiring changes over the years, so you might also have red and black and all sorts, but 3 core, and it's a heavier supply, and usually, like in this one, it's marked 240 on the back plate. So that's your supply, and if you're running on mains, the brown wire is our live, and if I imagine that the brown wire is where the electricity comes in, I can follow it through there, and it goes through this, which is the bit I said controls the temperature, and out the other side. Now it doesn't really control temperature, all it does is turns the heater on and off, and it turns it on and off based on this little capillary tube which goes down to the inside of the fridge and detects how cold or how hot the heater is. When it feels the fridge is cool enough, it will switch this off. So it just ticks between on and off, trying to maintain the temperature. If you've got it turned well up, then it will apply voltage for longer and turn off for shorter amount of time, because it's trying to maintain this temperature. So that comes out the other side of here and then through to this switch, and this switch is our switch that turns on or off the mains. So if the mains is on, through there, through this wire, down to the heater. The other brown wire is coming back from the heater that we just looked at on the back and goes to our neutral or blue wire back up our mains line. And as always, the earth that's coming out here is just going to the metal work of the fridge. So what we can do, I've got a reasonably cheap multimeter, which I'm going to set to read continuity or resistance. And you don't need to understand the details of resistance and ohms to use a meter like this. It's nice and straightforward. I'm just going to prop that up so that the camera can see it. So basically, once you've set it up for continuity, you'll typically get a 1 showing in your display. And what that means is there is no connection between these two things. When you connect them together, you should get a 0. There is no resistance whatsoever between these two connections. So they're connected perfectly. Move it, 1. Maximum resistance effectively, literally no contact. And in between, if you've got a half contact, so if I try and make a bad contact, you get all the other numbers. So when it's not touching, that's the reading that means no connection. Touching, 0, full connection. So what we'd like to see, for instance, is this earth wire comes in from our mains. I'm touching that. In theory, that is connected to everything metal that's on this fridge. So I'm going to touch some bare metal over here. Oops. I was getting 2,000 ohms, but I've now, by scratching the metal, got it down to 0, although it twitches. So no resistance, so they're perfectly connected. Now with our heaters, what we want to know is there should be a resistance. They work by the electricity struggles to get through, so it heats it up. So if I connect to both ends of this brown wire that goes to the heater, one there and one there, I've got a resistance, 0.48. That's good, because it means they are connected, but it's difficult. That's brilliant. Now, if I play with the switch on the front here, at the moment I've got it switched to mains. So the heater looks good, it's got some resistance to it. I switch it to the off position, and all of a sudden we get that 1 that says there is no connection whatsoever. I take the terminal off, it makes no odds. So that's good. It means the switch is working and the heater looks like it's working. If I switch this to 12 volt, it still doesn't fire. It just still doesn't connect up. So that's good. That means the switch is doing all its right jobs. Back to the mains, and yeah, there is a connection. Brilliant. We can do the same with the 12 volt heater. Now, 12 volt heater doesn't have any connection with this thermostat. It is just switch on or switch off. And that's because the 12 volt's less effective anyway. You'll need it on all the time. Hence, it'll drain your battery. So I'm going to connect to the... So in this, the 12 volt heater is not working. So I either can accept that and I've got a two-way fridge, works on mains, works on gas. Or try to buy a new heater that matches the one I've got on there, and it's easy to replace. Just pull that tube out as you've seen, disconnect these two wires, plug in the new ones, or bin the fridge. Now, for my purposes, a gas and 240 fridge is more than adequate, so I'll stick with that. So I'm just putting this back together now. Made the comment that fridges are cheap. Actually, if you try and buy these things new, they are really quite expensive. Too expensive, particularly when you know it's basically an insulated box with a heated chimney pipe and, yeah, a little closed circuit of ammonia, but there's nothing to them whatsoever. So when I say they're cheap, they're very expensive to buy, but second hand, they're really cheap because people are scared of them. People don't understand them, and they're really easy to pick up second hand. So for this scenario here, unless you've got another fridge that you can easily swap out the heater, I'd just say this one is a two-way. That's where it is. Or I would bin it and I would get another one for about £30 in the UK. Probably one that doesn't work. Do the ammonia trick on it, see part 1, and then you've got another working fridge. So really cheap second hand, rather expensive new, simple as. That is fridges. Hopefully you enjoyed that, guys. There's nothing clever to show. If you enjoyed this, then please consider subscribing to the channel. Costs you nothing, and if you click subscribe, then click the little bell icon, then you'll get alerted when there's new videos out on the channel. All manner of things that you can do in your shed and garage. Be really interested to see your comments on this one. See you soon.